Welcome students in the next session of electromagnetics. So in this sessions we are going to study about the introduction of electromagnetics. But before we start the introduction of electromagnetics, we need to understand what is meant by Coulomb's law, because without understanding the Coulomb's law we cannot understand what is meant by the electromagnetic. So let us first understand the Coulomb's law for forces between two charges. Okay, so let us consider the two charges, that is 2 point charges q1 and q2, and the distance between these two charges is nothing but r, and this can be represented by r12, that is small r12. Now according to the Newton's law, the force between the 2 point charges is represented by the magnitude of vector F, that equal to 1 upon 4 pi epsilon naught, 4 pi epsilon naught into q1 into q2 divided by r12 square of the distance between the two charges, which is generally represented in the SI units. Okay, so from this you can understood that the meaning of epsilon naught. So epsilon naught is nothing but the permittivity of the vacuum, and the distance between the two charges is nothing but r12 square. When we square, so from this relation we can understand that if the distance between two charges has been increased, or square of the distance between the two charges, then the force is reduced by a factor of 4. Again, from this relation we can understood that this force is directly proportional to the product of these two charges q1 and q2, and it is inversely proportional to the square of the distance between them. Okay, so that is according to the Coulomb's law. Here we can understand that the force of attraction or repulsion between two charged bodies is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. Okay, so we will understand next what is mean by attraction or repulsion between the two charges. Two charged bodies are there, but here from this relation you can easily understood that this force is directly proportional to the product between these two charges and inversely proportional between the square of the distance between them. That is, it act along the line joining. It act along the line joining of the two charges considered to be a point charges, right? So now here, once we understand the relation between the force and the charges, and in between the relation, now this force, that F, it is not a only quantity or the magnitude, but it also has the direction. Okay, so from this, can we tell me what is the direction of that force? Okay, so first we will understand now what is the direction. Once we understand the magnitude of that force, now we will understand what is the direction of that force. Okay, so here for direction of the force, if here you can understand in this slide you can understand that if the q1 and q2 are of the same sign, means charge signs are same, only positive positives are there, or we can say it is a negative negatives are there, then the force act between these two charges is nothing but the repulsive force, means along the line. Okay, and if the sign of these two charges q1 and q2 are of opposite sign, then the force acting in between is a attractive force. Let us understand in a different, in a another manner. Let us consider that two charges q1 and q2 here. Okay, and the distance between these two is nothing but r12. If the sign of this q1 charge and q2 charge is same, then the force is act along the lines, that is known as the repulsive force. Okay, and if this q1 and q2 do two charge bodies have opposite sign, then it's known as the attractive, then force between these two are attractive forces are there, that is by nature. Okay, so therefore we can represent the force F1 is like this, that is F1 equal to, it's a vector 1 upon 4 pi epsilon naught we already know, q1 into q2 divided by r12 square. In addition, it is known as r12 cap. So what is meant by r12 cap? It is represented as a unit vector along the direction of r12. Okay, so when the forces are opposite in direction, then sign will be, some sign has been changed, that is negative sign. Okay, and if the same signs are there, then opposite signs are there, then the equation of the force is like this, that is 1 upon 4 pi epsilon naught into q1 into q2 divided by r12 square into r21 cap. Okay, so it is r12, it is nothing but the distance from 1 to 2, and r21 is nothing but the distance from 2 to 1. So whereas in this equation r12 square or r21 square is nothing but one of the same is there, so here no need to represent the r21, okay, separately. So you can represent r12 square, it is sufficient because the square of these things are there. Okay, so this way we can calculate the force between the two same charging body or opposite charge bodies are there. Okay, so now specifically now we can represent the what is meant by Coulomb's law is like this. So there are two bodies are there, q1 and q2. So this direction is represented by r12 vector bar, and here is r21 vector. Okay, that is from force like 2 to 1, and here is represented by 1 to 2. Okay, and this force act as F1 equal to 1 upon 4 pi epsilon naught q1 into q2 r12 square and into r12 cap, that is a unit vector represented. Similarly, that force F2 due to the charge q2 is that equal to 1 upon 4 pi epsilon naught q1 into q2 divided by r12 square into r21 cap. Okay, so here is 2 1 cap, not 1 2 cap. So this is about the Coulomb's law. So once we understand what is meant by Coulomb's law, that is a basic. Coulomb's law is nothing but the force of attraction or repulsion between two charged bodies is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. Okay, and it acts along the line joining of the two charges considered to be a point charges. So this is about the Coulomb's law. Now next is nothing but, and this force that due to the that force is also have magnitude as well as direction. Okay, so now after that we'll understand this Coulomb's law by doing some experiment. Okay, by doing some experiment and by taking some of the examples and an assignment in the next session. Okay, so till then, thank you.